Okay. So third unit, combinational circuits. Okay. So first of all, digital circuits are classified into two types, right? Digital circuits, which are classified into two types. So one is combinational circuits, and the second one is sequential circuits. Okay. So first of all, we will discuss about the differences between these two circuits, combinational circuits and sequential circuits, right? After that, we will move on to combinational circuit topics. Okay, right here. So what is meant by combinational circuit? Okay, and what is meant by sequential circuit? Okay, so we have three basic differences. Okay, so those are very important. Okay, and here in this combinational circuits, the present output depends on present input only. Okay, the present output depends on present input. That means two things, two variables. Otherwise, I will take one diagram. So this is input, okay, and this is output. And in this black box, we are using one electronic circuit, right? So digital circuit. This you can consider digital circuit. For that digital circuit, I am providing input, I am getting output. This output, okay, this output variable and this input variable, both are, that means the output depends on this particular input. The output depends on present input only. Okay, present input. The output depends on present input. That means what? At one single instant, this output and input both are dependent. Okay, at one particular instant, the output and input both are dependent. At that particular instant, the output depends on input. Only one single time instant. Okay, that you have to remember. Okay, one single, otherwise single time instant. Okay, single time instant. At this time instant, the output depends on input. Okay, output depends on input. This single time instant, right? For this single time instant, we can call it as present state. Okay, present state. We can call it as present state. Okay, okay. This is about the combinational circuit. The present output depends on present input. So here we have a chance for present state only. Okay, and we don't have any previous state and we don't have any future state also. Okay, only present state. అంటే రైట్ నౌ ఏదైతే జరుగుతుందో దాన్ని మాత్రమే ఇక్కడ కన్సిడర్ చేస్తున్నాం. ప్రజెంట్ స్టేట్ సింగిల్ టైమ్ ఇన్స్టాంట్. ఓకే, ద అవుట్పుట్ డిపెండ్స్ ఆన్ ఇన్పుట్ ఎట్ దట్ పర్టిక్యులర్ టైమ్ ఇన్స్టాంట్. ఓకే, that will indicates the combinational circuit. In this combinational circuit, we don't have any previous state consideration and future state consideration, which completely depends on present state considerations. Okay, so what about sequential circuit? So we want to discuss about differences between these two, combinational and sequential circuit. Here the combinational circuit depends on only present state. Means what about sequential circuits? This will depends on present as well as previous state, right? So here also same thing, just I am taking one electronic otherwise a digital circuit, right? So I am taking digital circuit, so I am providing input here. Okay, I am taking output at this point. Okay, so and this output, okay, this output depends on present state and previous state also. Okay, here I am getting two words, right? one is the previous state, okay, previous state, and the second word is present state, okay. So this output depends on present state as well as previous. Present state means already you know, that means the output variable and input variable both are appear at one particular instant. That means output depends on input at that particular instant. That is called combinational circuit, otherwise present state. So here output depends on present input as well as previous output. That is very important. Previous output means the previous case, whatever the output we have, that will assigned as a input to the next state, okay. For example, in the first initial case I am getting certain output, whatever the output I don't know, okay. So that output is again I have to consider as a input to the this particular circuit, right. First I am getting certain output, I am taking that output and again I am providing as a input to this particular circuit. In this particular time, I am providing one particular input, and this previous output, this one is what? Previous output, right? Previous output. ఓకే, మనకి ఏముందో తెలియదు అవుట్పుట్లో, సర్టెన్ అవుట్పుట్ అనేది జరిగింది. ఆ ఇన్స్టెంట్ వదిలేసేయండి, ఆ ఇన్స్టెంట్లో జరిగిన అవుట్పుట్ని నేను మళ్ళీ నెక్స్ట్ ఇన్స్టెంట్లో ఇన్పుట్గా ప్రొవైడ్ చేస్తున్నాను. నెక్స్ట్ టైం ఇన్స్టెంట్లో ఇదే సర్క్యూట్కి ఇన్పుట్గా ప్రొవైడ్ చేస్తాను. ఆ నెక్స్ట్ టైం ఇన్స్టెంట్లో కరెంట్ ఏదైతే ఇన్పుట్ ప్రొవైడ్ చేస్తున్నాం, అంటే కరెంట్ ఇన్పుట్ అండ్ నెక్స్ట్ ఇన్స్టెంట్లో ప్రొవైడ్ చేస్తే ప్రీవియస్ అవుట్పుట్, ఇవి రెండు కూడా దీనికి ఇన్పుట్లా అప్లికేబుల్ అవుతుంది, రైట్. అప్పుడు ఫర్దర్గా నీకు అవుట్పుట్ అనేది getting out. So that output depends on this previous output, that is called previous state, okay. Previous output in the sense what? Previous state. And current input, this is current input. Current input means what? Sorry, this previous output means what? Previous state, right. And current input means what? Present state. That means the output depends on previous output and current input, then it is called as sequential circuit, okay. Simply here I am writing the output, okay. The output depends on present input and previous output, then it is called as sequential circuit. Then it is called as sequential circuit. So that is the difference, okay. Present output depends on present input only, then it is called combinational circuit. And present output depends on present input as well as previous output, then it is called as sequential circuit. Once you observe here, so here the output depends on this previous output and current input, okay. Current input and previous output, right. Otherwise present input, okay. So once you observe, if you are providing this previous output to previous input as a input to this particular circuit in the next instant, okay, up to that instant you have to store this particular data, right. Here we are getting certain output means what? Certain data, right. So that data you have to hold for next time instant to provide as a input to this particular circuit. So for example, I am at 0, okay, I am at 0 instant here, okay. So here I am providing current input at 1 second, first second, okay. So now I am getting output at 0 instant, 0 time instant. Now I have to hold this data up to first second, right. I have to hold this previous output up to first second, then I have to provide as a input to this particular digital circuit, right. Until that 1 second I have to hold this particular data. How to store that particular data, how to hold that data? With the help of memory, right. In order to hold, that means in 0 to 1 second I have to hold this particular data with the help of memory elements, where you can keep the element, where you can keep the memory elements in between this particular path, right. Here I will consider one memory element, just I have to store this previous output in this memory block, okay, up to 1 second, okay, up to first second. So once I'm getting the required time instant, just I have to provide the input to this particular digital circuit. But until that time, I have to store this data in this particular memory element. That means what? Sequential circuits will require memory elements to store the previous output, right? Sequential circuits will require memory elements to store the previous data, right? So that is the difference between combinational and sequential. Why? Because here only output, here we have only input at one particular time instant. This output depends on input. That is same instant, right? So here we have, that means this entire circuit depends only on present state. We don't have any other states, right? That complete combinational circuit depends on present output, depends on present input, so that we can we have a possibility to get only present state. So that's why we don't require any memory elements in this combinational circuit. But whereas in sequential circuit, the output depends present input, and same time that depends on previous output also. So the previous output, in order to store that the previous output, we required memory element in sequential circuit. So that we'll consider a second difference while comparing to combinational circuit. This is the first difference, right? The present state and previous state, that is the first difference between combinational and sequential circuit. And when it comes to second difference, these circuits will not have any memory elements, memory elements. And when it comes to this sequential circuit, this will have memory elements, right? This will have memory elements to store the previous data. Okay, this will have memory elements to store the previous output. Okay, and what is the third difference? Can you tell me the third difference by observing these two circuits? Can anyone tell me the answer? That is third difference. I want third difference from combinational circuit to sequential circuits. Can you type on chat box? No problem. Single input. Okay, both are having single input only. So, okay, your intention is this one having a present input and a previous output, right? So that's why you are considering two inputs. Okay, that is also okay, no problem. Next, any other? Please respond. Okay. Okay, that is okay. Two outputs, okay. Other than that, two outputs are required carry. I don't think so. Okay. Here we don't have any carry. Okay. We have only current input and previous output. Okay. Those are the two inputs. That is okay. Other than that, any differences? Time taking. Okay, that already I am providing at that particular instant, right? Until that time I have to hold the data. Okay. So there is no time difference. Okay. 1 second వరకు నేను వెయిట్ చేసేసి దాన్ని సెండ్ చేస్తున్నా కదా, అంటే పర్ఫెక్ట్ టైంలోనే అది అప్లై అవుతుందని దాని మీనింగ్ అక్కడ. One have memory, another don't have memory. I already told you that memory difference is there. Okay. Performance speed. Okay, that is also matter. Okay. Any other? Less complexity. Okay. Okay, anyway. So now coming to third difference. So here you can observe. So to produce the previous and present state, so we required feedback connection. Okay. So here I am providing feedback connection. Okay. To provide the previous output as a input to this particular digital circuit, I need to consider this feedback. Without this feedback, I cannot apply this previous output as an input to this particular digital circuit. Am I right? Okay, but whereas in combinational circuit that feedback is not required. Why? Because this output, present output depends on present input only. So here we are dealing with only present state, so that we don't require feedback connection in combinational circuit. But in the case of sequential circuits, we are dealing with the present state as well as previous state. So that for previous state point of view, we require feedback connection. That is the third difference. Can I consider that as a third difference? The third difference here is we don't require feedback, right? Here we require feedback. Here we require feedback to maintain the previous state. To maintain the previous state. Okay, this is third difference. And you can write some more differences also. Some people are less complexity. Combinational circuits are less complex, sequential circuits are more complicated. Okay, so like that you can provide some more differences. Okay, these are the main differences: memory element, feedback element, and present state, and present and previous state. These are the fundamental differences between combinational circuits and sequential circuits. Okay, so that you have to remember. Okay, and the next one. Okay. So here combinational circuits and the sequential circuits. So here we have some examples. So under this combinational circuits, first arithmetic circuits. Arithmetic circuits, those are half adder and full adder, and half subtractor and full subtractor, and next binary parallel adder, and read only memory, and next encoder and decoder, and multiplexer, mux అని అంటాం. Okay, you can call it as mux, multiplexer, MUX, and demultiplexer, otherwise demux. Okay, demultiplexer, otherwise demux. Okay, and next one. So these are the half adder, full adder, half subtractor, and full subtractor. These four devices will consider as arithmetic circuit. And next are binary parallel adder, ROM, read-only memory, encoder and decoder, multiplexer and demultiplexer. These are comes under combinational circuit. That means what? These are all the devices. Okay. So these are all the circuits. Don't call it as devices. These are all the circuits depends. These are all the circuits outputs depends on present input, and these all are working with respect to present state only. That's why we can call it as combinational circuits. Okay, these are all the devices working with the present state only. That means present output depends on present input only. That's why we can call it as combinational circuit. And when it comes to sequential circuits, we have here we have serial order examples. Serial adder. Here we have binary parallel adder. This one also binary serial adder only. So because we are using binary numbers in our digital electronics, so that's why binary parallel adder. Okay, don't always write binary, parallel adder. That is enough, right? And here parallel adder comes under combinational circuit, and serial adder comes under sequential circuit. Why? Because this depends on a present state as well as previous state. Okay, and the next example, that is state machines. Okay, state machines. And the next one, RAM. Okay, random access memory. Okay, a random access memory. Okay, and the next one, registers. Okay, registers and counters and sequential generator. Otherwise sequence detector. Okay, sequence detector in nothing but generalized example I will tell you. So in your mobile you can kept one మీరు మొబైల్లో ఒకటి ప్యాటర్న్ పెట్టుకుంటారు కదా, ఐ మీన్ లాక్ అన్లాక్కి. ఓకే, అన్లాక్ చేయడానికి కానీ లాక్ వేయడానికి కానీ ఒక ప్యాటర్న్ పెట్టుకుంటారు, రైట్? సో దట్ వర్క్స్ with the help of the sequence detector. Okay, anyway I will explain in this particular fifth unit. Okay, so these are the examples of combinational circuits as well as sequential circuits. Okay, so entrance exam lo idi kuda important. Okay, so meeku which one of the following is the combinational circuits అని చెప్పేసి option A serial ladder, option B state machine, option C RAM, option 4 బైనరీ ప్యారలల్ యాడర్. సో అలా మెన్షన్ చేయడానికి స్కోప్ ఉంది. ఓకే, సో స్టేట్ లెవెల్ ఎగ్జామ్లో ఇలాంటి క్వశ్చన్స్ మనకి రావడానికి స్కోప్ ఉంది. ఓకే, సో నెక్స్ట్ వన్, ఓకే, సో ఫస్ట్ వన్ హాఫ్ యాడర్. ఫస్ట్ we will discuss about arithmetic circuits, right? In that first one is half adder. Okay, now so here a logic circuit for the addition of two 1-bit numbers is called as half adder, and it generates sum and carry. Okay, so half adder is nothing but which performs 1-bit addition, right? A logic circuit for the addition of two 1-bit numbers. For example, already we know about binary addition, right? So what is binary addition? So if we are adding 0 plus 0, we are getting 0, 0 plus 1 equals to 1, and 1 plus 0 equals to 1, and 1 plus 1 equals to sum 0 and carry 1, right? Sum 0, carry 1. Okay, that's fine. So this is binary addition. How it perform with the help of digital circuits. Okay, how this addition, this 1-bit, this is 1-bit, this is also 1-bit, right? This 1-bit addition can be performed with the help of this half adder. Okay, for example, in the case of 0 0 plus 0 1, this is what 2-bit addition. In case if you add 0 0 0 plus 0 1 0, this is what 3-bit addition, right? So this 1-bit addition will be performed with the help of half adder, right? So next, so now for example, first 3 cases we are generating sum, right? 0 plus 0 we are getting sum, 0 plus 1 we are getting sum, 1 plus 0 we are getting sum. When it comes to this fourth case, we are getting sum as well as carry also, right? Sum and carry. So in the second point, it generates sum and carry. For example, if you are taking first bit is 1 and the second bit is 1, so I am getting 0 sum. This is your sum, okay, and this one is your carry. So 1 1 0 sum and carry. This is your carry, okay. So sometimes based on application, based on the situation, so this one can be treated as overflow also, okay, overflow. So this is one bit addition, so that we can call it as carry. For example, if I am taking 0 0 1 and 0 1 0, so this is a 3-bit addition. If I, sorry, 0 1 1, okay, okay. So for 1 1 means a sum 0 and carry 1. That means this carry is forwarded to next bit addition. This is first bit addition, this is second bit addition, this is third bit addition, okay. In the first bit addition we are generating this carry, right? So we have sum, and in the same way we are getting a carry, okay. That carry is propagated to second bit position, okay. In that case this carry should be considered as overflow, okay. That means one bit position to another bit position, if any carry exists, that can be treated as overflow. That is clear, okay. But here we have this half adder performs only single bit addition, so that we can call it as carry, okay. So that you have to remember, half adder which generates sum as well as carry, okay. Now, so in order to perform this one bit addition, so what are the circuit we require? That is very important. How to implement the circuit to perform this half adder, how to implement the circuit to perform this one bit addition, okay. In the general case lo manam 2 bits ni add chesesi 0 vastundi 1 vastundi ani cheptunnam, but circuit ela danni అనలైజ్ చేస్తుంది, సర్క్యూట్ ఎలా దాన్ని కంప్యూట్ చేయాలి. ఇప్పుడు మనం క్యాలిక్యులేటర్కి ప్రొవైడ్ చేస్తున్నాం 0+1, అది 1 అని మనకి డిస్ప్లే పైన చూపిస్తుంది, ఓకే. అది ఎలా పాసిబుల్ అవుతుంది? బిహైండ్ దట్ అసలు ఏ డివైజెస్ యూజ్ చేస్తున్నాం, ఆ కంప్యూటేషన్స్ అని ఎలా జరుగుతున్నాయి అంటే దానికంటూ ఒక పర్టికులర్ సర్క్యూట్ అనేది ఇన్సైడ్ ద క్యాలిక్యులేటర్ మనం యూజ్ చేస్తున్నాం, రైట్. ఆ సర్క్యూట్ ఏంటి? హాఫ్ యాడర్. హాఫ్ యాడర్ ఎలా, హాఫ్ యాడర్ డిజైన్ అనేది ఎలా ఉంటుంది, అది ఇప్పుడు మనం ఇంప్లిమెంట్ చేయాలి, ఓకే. So this is about a half adder, so which performs one bit addition and which generates sum as well as carry, right. So now, so symbol of half adder, symbol of half adder, this is IEEE symbol, right. Okay. HA means half adder, okay. Here I am providing 2 bits, right. So for 1 bit addition we require 2 bits, right. So this is 1 and this is 1. So here I am getting 0, sum 0 and carry 1. So I am indicating carry here, right. This is 1 bit and this is 1 bit, right. So these 2 bits are provided for 1 bit addition, okay. This is 1 bit addition, so that means 1 bit we can add here, 1 bit addition. So we'll require 2 inputs, right. We'll require 2 inputs, okay. This is A input and this is B input. That means this should be considered as A and this should be considered as B. So these 2 inputs are provided to this particular half adder. Then I am getting sum, okay, and I am getting carry here, okay. Okay, now, so ఈ బ్లాక్ బాక్స్లో మీకు సర్క్యూట్ అనేది ఎగ్జిస్ట్ అవుతుంది, ఈ అడిషన్కి సంబంధించిన సర్క్యూట్ అనేది ఎగ్జిస్ట్ అవుతుంది. బట్ ఆ సర్క్యూట్ రావాలంటే ఫస్ట్ మనకు సమ్ ఎక్స్ప్రెషన్ కావాలి అండ్ క్యారీ ఎక్స్ప్రెషన్ కావాలి. నేను ఏబి అనే వేరియబుల్స్ ఇన్పుట్గా ప్రొవైడ్ చేశాను, రైట్. ఐఎమ్ ప్రొవైడింగ్ ఏబి, దీస్ 2 are వేరియబుల్స్, దీస్ 2 are input variables for this particular half adder, okay. So this will generate sum and this will generate carry, okay. So what is the sum expression and what is the carry expression? If you know the sum and carry expression, then you can able to design this particular half adder circuit, right. First you need to find out sum expression, after that carry expression. So if we are getting these 2, then obviously we can able to design this particular half adder, okay. First I will take these 2 input variables. I come with I am coming with this input variables, right. So I am taking input variables A and B here, okay. 2 input variables means what? We can expect 4 combinations, right. 0 0 0 1 1 0 1 1, okay. Just I am indicating here 0 0, this is one possibility, 0 1 1 0 అండ్ 1 1. ఓకే, అంటే మీరు 2 ఇన్పుట్స్ని కనుక ఈ హాఫ్ ఆర్డర్కి ప్రొవైడ్ చేయాల్సి వస్తే ఇన్ని వేస్గా మీరు ఫామ్ చేయొచ్చు ఇన్పుట్స్ని. 0 0 1 పాసిబిలిటీ, 0 1గా తీసుకోవచ్చు, లేదా 1 0గా తీసుకుని 1 1, అంటే ఇక్కడ ఇలా వస్తుంది, రైట్? సో ఫస్ట్ 0 0 కేస్, ఓకే, దిస్ ఈజ్ 1 పాసిబిలిటీ, ఇలా అరేంజ్ చేయొచ్చు. లేదు అని అంటే 0 1, దిస్ ఈజ్ సెకండ్ పాసిబిలిటీ. లేదు అంటే 1 0, లేదు అంటే 1 1. సో ఇలా మీరు 4 వేస్లో ఇన్పుట్స్ అనేది హాఫ్ యాడర్కి అప్లై చేయొచ్చు, రైట్? సో నెక్స్ట్, ఒకవేళ 0 0 మీరు ఇన్పుట్గా ప్రొవైడ్ చేశారనుకుందాం, ఓకే. సో దిస్ ఈజ్ 0 కండిషన్, 1 2 3. సో టోటల్ 4 పాసిబిలిటీస్, దట్ ఈస్ ఫ్రమ్ 0 to 3. సో 0 0 అప్లై చేశారు. 0 0 యాడ్ చేస్తే మీకు ఏమొస్తుంది ఇన్ జనరల్గా? సో ఐఎమ్ టేకింగ్ హియర్ సమ్, ఓకే, అండ్ హియర్ క్యారీ, ఓకే. సో 0 0, if you add these 2 bits, I am getting 0 sum and carry 0, and 0 1 1 carry 0, and 1 0 I am getting sum 1 carry 0, 1 1 I am getting sum 0 carry 1. So this is your truth table, right? Okay, this is your truth table. Okay, from this truth table you can develop the boolean expression for this sum as well as this carry. Okay, here we have sum column, right? In this column certain combinations are in active mode. For example, if you take this first and second combination, 0 comma 1 1 comma 0 combination, will have active outputs, right? 1 1 for this sum only. I am not focusing carry. Okay, first I am focusing with sum. In this sum only these 2 possibilities are active mode, okay, with respect to output point of view. Okay, so if you want to find out boolean expression for this sum, you can take the k maps. Okay, already I told you. So in order to find out the minimal boolean expression, okay, we have to go for k maps, right? So this is 2 variable, you can directly write from this truth table also, but anyway first we will take the k map. After that we will find out the boolean expression for this sum as well as carry also. Okay, so 2 variables means we will get 4 square boxes, right? So this is for sum. Okay, so for this sum, so we have 4 square boxes. 2 variables means 2 power 2, we will get 4 square boxes. Okay, so these are the 4 square boxes, and a variable and b variable, right? Now so first you can arrange the number sequence, that is 0, this is 1, this is 2, and this is 3, and this entire row will indicate with a b bar and b, and this, that means this is what 0 and this is what b. So this 0 can be indicated with b bar, and this can be indicated with b, and this is 0 and this is 1. So this can be indicated with a bar, and this can be indicated with a, right? So now you can take these output values, sum value, because the sum is activated for this first combination, and this sum is activated for second combination. I am considering in sum of product mode. Okay, that is also very very important. Okay, in the sum of product I am taking 1 as an active combination and 0 as a inactive combination. When it comes to product of sum, 0 as consider active combination, 1 should be considered as inactive combination, right? So I am familiar with sum of, you can follow any method, you can go with the product of sum, and you can go with sum of product. So in both the cases you will get same answer, same implementation, same circuit, but here I am familiar with sum of product, so that I will take sum of product only. Okay, now okay, so this first combination, okay, and the second combination both are having 1, and remaining all are 0. Now you can form the pairs. So is there any possibility to get the 2 squares pair, otherwise quad? Okay, so we don't have any possibility. Okay, this one should be considered as an individual, and this one also should be considered as individual. So you can write the expression for these 2 square boxes, then what you will get? So that equals to, the sum equals to, okay, for this one, so which is accommodated with B as well as A bar. So that I am getting here A bar B plus, and for this square box, this square box is associated with A as well as B bar. So that I am getting A into B bar. Okay. So this is your expression. So this is we can able to write directly also because of two variables. So we can write directly. How you can write? So this A should be considered as 0. Just you can focus on active combinations only. In the sum column, we have these two only active combinations. So in that for these two active combinations only you can focus. So this A having 0 and B 1. In sum of product, A equals 0 means A should be considered as the complementary variable, right? A bar. And in the sum of product, B equals to 1 means B should be considered as uncomplementary variable, right? So in that sum of product, we are considering min term, right? Min term, otherwise product term. Okay, so that's why here I am indicating A bar, A equals 0, so that I am taking A bar, and B equals to 1, so that I am taking B. So this is sum of product, so that I have to consider min term or product term, so that I am taking product of these two variables A bar B, and here I am getting sum 1. Okay, and I will multiply with the 1 here. Okay, and next one plus. Okay, next second combination, here A having 1, so A equals 1 means A, B equals 0 means B bar. Okay, for that output equals to 1, so I am getting 1. So now you can multiply something with 1, so obviously you will get something only, right? So you can multiply 1 with something means you will get something only. So that what is the answer here? A bar B plus A B bar. Okay, so this is your output. Just you can directly write from this particular table. Okay, don't go for this K maps. Okay, so for 2 or 3 variables you can directly write. Okay, when you come across 4 variables, definitely you can use this K map. Why? Because మిస్టేక్స్ వెళ్ళడానికి స్కోప్ ఉంటుంది 4 వేరియబుల్స్. సో ఆ టైంలో మీరు కే మ్యాప్ కంపల్సరీ యూస్ చేయండి. బట్ 2 or 3 వేరియబుల్స్ అయితే కనుక మీరు డైరెక్ట్లీ ట్రూత్ టేబుల్ నుంచి వెళ్ళి రాయొచ్చు. ఓకే, ఇది రాసే మెథడ్. ఓకే, సేమ్ వే ఈ క్యారీ కూడా అప్లై చేయండి. సో సమ్కి నాకు ఇది ఆన్సర్ వచ్చేసింది ఏ బార్ బి ప్లస్ ఏబీ బార్. దిస్ ఈజ్ అవర్ బూలియన్ ఎక్స్ప్రెషన్. ఫ్రమ్ దిస్ బూలియన్ ఎక్స్ప్రెషన్ వీ కెన్ ఇంప్లిమెంట్ ది సర్క్యూట్, రైట్? సో దట్ ఈస్ ద ప్రొసీజర్. ఓకే, అండ్ నెక్స్ట్ ఐఎమ్ టేకింగ్ క్యారీ. ఓకే, సో దిస్ ఈస్ క్యారీ. Okay, so here, so you can directly write from this particular truth table. Why can't I am taking this 0 combinations means if you multiply this entire combination with 0, you will get 0 only. Okay, that's why I am not taking this 0 values. Okay, here I am taking only active combination. Why I am taking active combination means if you multiply these active combination with this min terms, you will get same answer, right? So but when you multiplying 0 with this entire product term, so you will get 0. That's why I am not considering the 0 value. Here also same thing. These all 3 combinations having 0 values, so that you can't take these 0 values. If you are taking also, you will get 0 only. Okay, that's why you can take only active combination, that is 1, fourth combination. In this fourth combination, A is 1. A is 1 means you can consider A only, and B equals to 1, that is also uncomplementary form, so that you can take B, and these are in product, that means multiplication form, AB, and this again multiplied with this carry term 1. Okay, just I am writing the expression. I am writing the expression for only this column. So don't consider this sum while taking this carry. Okay, if you are taking sum means you don't consider this carry. Okay, so now carry equals what? AB. So AB into 1 means what? AB. So you can directly write from this truth table. Otherwise you can go with K map also. This is also 2 variables, so that I am taking A, B, and 4 square boxes, 0, 1, 2, 3, and this is 0, 1, 0, 1. And here the third possibility having active combination, right? So that means 1. Okay, so that you can take only at this position you can indicate 1, and remaining all are 0. So for this one only you can write the expression. So that means this is what B bar, and this is one B, and this should be considered as A bar, and this should be considered as A. So now this entire square box accommodated with the A as well as B. Now what is your answer? So carry equals to A into B. So if you take any approach like this or like this, so you will get same answer. Okay, now finally what you will get? So sum equals to a bar b plus ab bar, and next carry equals to what? A into b. Okay, these are the Boolean expressions. So from the first you find out the Boolean expressions. From that Boolean expression you can implement the circuit diagram. Okay, from that Boolean expression you can implement the circuit diagram. The circuit diagram with the help of basic gates, universal gates, and extra gates. Okay, with the help of basic, universal, and extra gates you can implement the circuit, right? So if you observe this sum, already I told you for XR, okay, A, B, so the outcome is what? A XR B. The symbol indicates XR operation. This XR operation equals to what? A B bar plus A bar B, right? ఐడియా ఉందా? A XR B అంటే A B bar plus A bar B. ఒకసారి దీంతో కంపేర్ చేయండి ఈ రెండింటిని. So here A B bar. So here also we have A B bar, and here A bar B. Here also we have A bar B. That means both the product terms we can observe here, right? A bar B, A B bar. Okay, that means what? Can I write this as A XR B, right? So this combination is A XR B. That means sum is nothing but what? A XR B, and carry equals to what? One product term, right? A into B means what? This is one product term. So how you implement this product term? Okay, so we have some basic gates, right? So basic gates in one is NOT gate, and second one is AND gate, and third one equals to OR gate. NOT means what? Inversion. Okay, NOT means what? Inversion. AND means what? Product. Okay, OR means what? Addition. Okay, so each one particular gate having one speciality, right? AND is nothing but which provides the logic is what? Product. OR means what? The logic is addition. NOT means what? The logic is inversion, right? So here we have product, right? Product means multiplication. So we require in order to implement the product, so we go for this AND gate, right? In order to implement this XR operation, we need to go for this XR symbol, otherwise XR circuit, XR gate. Okay, that means in order to implement here, this is our half adder. Here we are providing A and B. These are the two input variables. Here I am getting sum, and I am getting here carry. Okay, so this circuit I want to implement, right? The circuit I want to implement. So for that I am calculating sum. For that I am so I found this relation, the sum relation, that is A XR B, and for carry I am getting AB. Okay, so for A XR B we require XR gate, that is clear. Okay, for this product we require AND gate. Okay, for this product we require AND gate. With the help of XR gate, with the help of AND gate, we can able to construct this half adder circuit, right? So now first I am taking XR gate here. Okay, after that I am taking one AND gate here. Okay, so first I am providing inputs to this particular XR gate. So finally I will generate the sum that equals to ఏమవుతుంది, ఈ XR గేట్కి AB ప్రొవైడ్ చేశాను. ఫర్దర్గా సమ్ ఏమొస్తుంది? A XR B, which is equals to A bar B plus A B bar. Okay, so now I want to produce this product. So in order to produce this product, so we have to use AND gate. Here I have AND gate. For this AND gate we have to provide two inputs. One is A, another one is B. Okay, if you provide A, B are variables to this particular AND gate, so we will get AB as a product, right? So that means the carry equals to this AB. Okay, so మీకు ఇన్పుట్స్ ప్రొవైడ్ చేయాలంటే ఇక్కడ నుంచి తీసుకోండి, ఇక్కడ నుంచి తీసుకుంటే సరిపోతుంది కదా. Okay, so from this you can provide A, and from this you can provide B. Okay, now సో ఇక్కడ మీకు ఇలా యూజ్ చేశాను కదా. సో ఇక్కడ నుంచి నేను కనెక్షన్ తీసుకుంటున్నాను, ఒక డాట్ మార్క్ పెట్టేస్తాను, ఇలా తీసేసుకొని ఇలా యూజ్ చేసాం. దాని మీనింగ్ ఏంటంటే ఈ వైర్కి మధ్యలో ఎలాంటి కనెక్షన్ లేదు అని దాని మీనింగ్, రైట్? మీరు ఇలా యూజ్ చేస్తున్నాను, ఓకే. సో ఇక్కడ నుంచి కనెక్షన్, ఈ డాట్ అనేది కనెక్షన్ని రిప్రజెంట్ చేస్తుంది. ఇలా యూజ్ చేశాను అని అంటే అక్కడ కనెక్షన్ ఏం లేదు అని చెప్పేసి దాని మీనింగ్, ఓకే. ఒకవేళ ఇక్కడ కనెక్షన్ ఉంది అని అంటే ఎలా రిప్రజెంట్ చేయాలి? ఇక్కడ ఒక డాట్ అండ్ ఇక్కడ ఒక డాట్ యూజ్ చేయాలి. ఒకవేళ డాట్ యూజ్ చేయకుండా డైరెక్ట్ మనకి ఇలా యూజ్ చేసినా సరే ఇది దీంతో కనెక్ట్ అయి ఉందని దాని మీనింగ్, ఇది కూడా దాంతో కనెక్ట్ అయింది, రైట్? సో ఇలా మెన్షన్ చేశాడు అని అంటే ఆ రెండింటికి మధ్యలో ఎలాంటి కనెక్షన్ లేదు అని దాని మీనింగ్, ఓకే. ఓకే, సో నా okay, so this is your half adder circuit. So now you can make your black box. This is your black box, okay. So inside this box we have one XOR gate and one AND gate, XOR and AND gate, okay. So here we are providing AB inputs and here we are getting sum and carry, right? That means to perform 1 bit addition we required half adder. For that half adder we required XOR gate as well as AND gate. So this is our circuit implementation. I hope you got some idea regarding this half adder, right? Okay, now okay, this is your half adder circuit. Now I will move on to half adder circuit, otherwise half adder realization. Half adder realization by using basic gates. Okay, so in the previous case what happened? This is XOR gate is nothing but extra gate, AND gate is nothing but basic gate, right? So this is basic gate and this is extra gate, okay. With the help of extra gate and basic gate, here I am using half adder. Here I am implementing this half adder, but here my question is what? Half adder realization by using only basic gate. Basic gates means what? We have 3 gates, those are NOT gate, okay, and second one is AND gate and third one is OR gate. So with the help of these 3 gates you can construct this half adder, okay. So don't use extra gate and don't use universal gates. That is the question, right? So how you implement? First of all we have 2 variables, right? A variable and B variable. For this 2 variable you can consider inverted variables also, okay. First here I am taking A, this is AY and this is BY, and at the same time you can provide inverted variables like that means okay. So here I am providing A and this is A bar, okay, this is B and this is B bar. So this B is connecting inverter, so inverter output is what? B bar. So this A and B are normal inputs, right? A bar and B bar should be considered as inverted variables, right? First you can form this type of configuration. After that, so what I want, sum is nothing but what? A bar B plus A B bar, this is sum, that is A XOR B, okay, and carry is nothing but what? A into B, that is product, okay. Okay, now for this product we required AND gate, right? So when it comes to this sum, A bar B, this is inverted input and this is normal input, this is normal input, this is inverted input. Already we have normal inputs as well as inverted input, that is clear, right? So now what you want? A bar B is nothing but product. For this product we required one AND gate, right? For this product we required one AND gate, and here one more product term also there, A into B bar, with a combination of inverted and non-inverted variables, okay. So this is one more product term. So one more product means in order to implement this product we require one more AND gate, okay. Here one AND gate, here one AND gate, here also we require one AND gate, and these two product, these these two products are added here, right? These two products are in a sum nature, right? So in order to add these two product terms, we require one OR gate, and employs the product, okay, or implements the or employs the sum term, okay, not means inversion, okay. To form the inverted variables, we need to go for NOT gate. So to implement the product terms, we need to go for AND gate. To implement the sum term, we need to go for OR gate, right? So that is the rule, okay. So now I am taking total we required three product terms, right? AB, A bar B, AB bar. For these three product terms, we require three AND gates. First, you have to indicate the three AND gates here, okay. This is one AND gate, and this is another one, okay, and this is last one, okay. First, I am providing so A bar B product term, right? So we require two inputs for this AND gate, that is one A bar, another one is B. Here we have direct A bar is there. So from this point, you can take A bar, okay. So while taking the connection, you don't connect this B and B bar, right? So in that situation, you can take like this, okay. If you are not using this symbol, okay, that wire is connected to B as well as B bar. For example, if I am taking like this, okay, so this wire is connected to B as well as B bar, okay, that is completely wrong, okay. Now, so and the second input is what? This is A bar, okay, this is clear. And the next input is what? B. So where is B? So this is your B. So from this you can take one connection, okay, this is B. And next A B bar. So next A into B bar. A is from this point, okay, and B bar. So B bar is this one, okay, this is inverted, okay. This is A and this is B bar, and this one is B, okay, and the last one is AB. So direct inputs, okay. So this is A and this one is B, okay. So finally, what is the outcome of this first gate? This is 1, this is 2, and this is 3. The first gate output is what? A bar B, okay, and the second gate output is what? AB, and third gate out, sorry, AB bar, okay, and third gate output is what? AB, okay. So this is our carry, right? So here I am indicating carry equals to AB. So carry is over. Now I want sum term. Sum term is what? A bar B plus AB bar. This is our product term, and this is also our product term. We need to add these two. So in order to add these two product terms, so we require one OR gate, okay. So here I am using OR gate, okay. So okay, now I am providing A bar B as one input, AB bar as one input. So finally, what is the outcome? The sum equals to A bar B plus A B bar, okay. This is your sum and this is your carry. So this entire thing is what? Half adder, okay. This half adder realization with the help of only basic gates. If you observe all these entire this circuit, so we have NOT gates, we have AND gates, and we have OR gate, okay. Only I am using basic gates to implement this particular half adder realization, okay. So this is one way of approach to realize this half adder, and the next one is half adder realization of H by A means half adder, okay. You can remember like this, half adder realization by using NAND gates only, by using NAND gates. AND gate means universal gate, right? Okay. So half adder realization by using only NAND gates, okay. NAND gates మాత్రమే యూజ్ చేసేసి సేమ్ ఫంక్షనాలిటీని ఇంప్లిమెంట్ చేయాలి. సో ఎలా యూజ్ చేస్తారు? సో వన్ థింగ్ యూ రిమెంబర్, మనకి హాఫ్ యాడర్ని ఇంప్లిమెంట్ చేయడానికి మనకు కావాల్సిన థింగ్స్ ఏంటి? సమ్ ఈజ్ నథింగ్ బట్ A XOR B, and the second one is product, okay. For this product we require that means one AND gate. here we required XOR gate, here we required AND gate. Okay, already I discussed about realization of NAND NOR gates in logic gates topic, right? That means realization of basic gate with the help of NAND, realization of basic gate with the help of NOR. Okay, realization of extra gate with the help of NAND gates, realization of extra gate with the help of NOR gate. Those all concepts already discussed, right? So in that case, so realization of XOR gate with NAND. So how many number of NAND gates required to implement this XOR logic? We required 4, right? Already you know about that particular thing, right? So this is your NAND gate. Okay, here I am providing A, B inputs, and here I am getting AB bar. So again this AB bar is providing as an input to next to 2 NAND gates. Okay, so so for this I am providing A as a direct input, and for this third gate I am providing B as a direct input. Okay, and now I am this is A and this is A bar B, sorry, A B bar and A B bar, this is B. So now these two are connected to one more NAND gate, so that is so finally what you will get, so A into A bar B whole bar, and this A B bar into B whole bar. So finally you will get outcome equals what, A B bar plus A bar B. This is your answer. So which can be directly you can write A XOR B. This is XOR operation. Okay, so this XOR logic gate can be implemented with the help of NAND gates. So with the help of 4 NAND gates we can able to implement this particular logic, right? This is already we know. Okay, so now, so one thing is over. With the help of these 4 NAND gates, so we can implement, we can able to implement this XOR logic. This XOR logic is what, sum, our half adder sum, right? But I want this AND logic also. That means the product, I want carry also. Okay, in order to implement this carry, I will take this output. Okay, I am focusing on this particular output. So here the output is what, AB bar, right? So if I am taking invert of this AB bar, I will get AB. That means I will get carry also, right? So how you get this inverted AB bar? With the help of NAND gate. Okay, how to create the inversion with the help of NAND gate? So just I am taking that means 2 possibilities we have, right? So I am taking 2 inputs tied with one input variable. If I am using 1 here, I am getting 0, right? For example, if I am taking A here, I am getting A bar. This is one way. And second way is what? So I am taking one input is 1, another one input is A. So this A into 1, I get, so I am getting A bar, right? That means bubble means inversion. A into 1 means A, that is AND gate output. Bubble means NAND gate, so A bar. So this is one possibility. So if you want to implement inversion mechanism with the help of NAND gate, we require this combination, right? You can use any one, but I am taking directly AB bar from this output. So I am providing this input to NAND gate. Okay, so AB bar. So same input I am providing 2 times, so that I am getting AB bar whole bar, so that AB. So this is our product term, right? This is carry, and this one is sum. So this is our half adder with the help of only NAND gates. Okay. Now you can observe, in order to implement half adder, okay, in order to implement half adder, so this is your half adder black box. Okay. Okay, so these are our inputs and these are our outputs. Okay, in order to implement half adder, so how many NAND gates are required? That is the entrance question. Okay, so 1, 2, 3, 4, 5. That means we required 5 NAND gates to implement this particular half adder realization. To implement XOR realization, we required 4 NAND gates. These 4 NAND gates are required to enough to implement this particular XOR logic. Okay, that is important. So you remember, to implement half adder circuit, we required 5 NAND gates. To implement XOR logic, we required 4 NAND gates. Okay, so and the next one, So here I am using NAND gates, right? Now your homework is what? So you can use NOR gates. Okay, to with the help of NOR gates you can implement half adder realization. So just I'm giving ఆన్సర్ కూడా నేను ప్రొవైడ్ చేస్తున్నా. ఓకే, ఇక్కడ 5 NAND గేట్స్ రిక్వైర్డ్ అవుతున్నాయి కదా హాఫ్ యాడర్ ఇంప్లిమెంట్ చేయడానికి. నర్ లాజిక్తో ఇంప్లిమెంట్ చేయడానికి కూడా మీకు 5 NOR గేట్స్ వచ్చేసి రిక్వైర్డ్ అవుతాయి హాఫ్ యాడర్ ఇంప్లిమెంటేషన్. ఓకే, otherwise I will conclude with one statement. Okay, that's better. First statement: to implement half adder with NAND gates we require 5 NAND gates. Okay, the second point: to implement half adder with NOR gates we require 5 NOR gates. ఓకే, ఆల్రెడీ నేను ఆన్సర్ ఇచ్చేసాను 5 NOR గేట్స్ రిక్వైర్డ్ అవుతాయి, బట్ దాన్ని ఇంప్లిమెంట్ చేయండి. ఓకే, ఏ కన్ఫిగరేషన్లో ఉంటే మనకి ఈ హాఫ్ యాడర్ రియలైజేషన్ అనేది పాసిబుల్ అవుతుంది, సమ్ కానీ క్యారీ కానీ జనరేట్ అవుతుంది. ఓకే, ఇది మీరు కన్స్ట్రక్ట్ చేయండి. ఓకే, దిస్ ఈజ్ యువర్ అసైన్మెంట్. ఓకే, అండ్ నెక్స్ట్, సో అండ్ వన్ మోర్ ఇంపార్టెంట్ థింగ్, IEEE symbol for this. Okay, here I am writing the ANSI symbol, otherwise IEEE symbol, otherwise IEEE standard logic symbol. Already starting lo ichchanu anukunta kada. Okay, so this is IEEE ANSI standard logic symbol. Okay, మీరు ఇలా యూజ్ చేసినప్పుడు మీరు అజ్యూమ్ చేసుకోవాలి, ఒక ఇన్సైడ్ ద బాక్స్ ఒక XR గేట్ ఒక AND గేట్ ఉంది అని చెప్పేసి. ఎవ్రీ టైం దాన్ని డ్రా చేయలేము కదా, అందుకని చెప్పేసి ఒక బాక్స్తో రిప్రజెంట్ చేశారు. ఓకే, ఎక్కడైనా మనకు అప్లికేషన్ హాఫ్ ఆర్డర్ అప్లికేషన్ వచ్చిందంటే మనం ఈ సింబల్ యూజ్ చేస్తే సరిపోతుంది. ఎవ్రీ టైం XR గేట్ కానీ అండ్ ఆ కన్ఫిగరేషన్ ఆ కనెక్షన్స్ యూజ్ చేయాలన్న రూల్ అయితే లేదు. ఓకే, ఈ బాక్స్ యూజ్ చేస్తే సరిపోతుంది. ఓకే, అండ్ వన్ మోర్ క్వశ్చన్, దట్ ఈస్ థర్డ్ క్వశ్చన్. So realize half adder circuit with minimum number of gates, by excluding XR and XNOR gates. ఓకే, క్వశ్చన్ అర్థమైంది కదా. హాఫ్ యాడర్ని ఇంప్లిమెంట్ చేయాలి, మినిమం నెంబర్ ఆఫ్ గేట్స్ ఉండాలి, ఆ గేట్స్లో XR కానీ XNOR కానీ యూజ్ చేయాలి. మీకు అవైలబుల్గా ఉన్న గేట్స్ ఏంటి? నాట్ గేట్ అండ్ AND గేట్ అండ్ OR గేట్, దీస్ ఆర్ ది బేసిక్ గేట్స్. ఓకే, అండ్ NAND, NOR. ఓకే, సో దీస్ ఆర్ ది యూనివర్సల్ గేట్స్. అండ్ XR, XNOR, దీస్ ఆర్ ది ఎక్స్ట్రా గేట్స్. అంటే ఈ ఎక్స్ట్రా గేట్స్ లేకుండా ఓన్లీ ఈ 5 గేట్స్ని మాత్రమే యూజ్ చేసి రియలైజ్ చేయాలి, అండ్ దట్ టు మినిమం నెంబర్ ఆఫ్ గేట్స్ ఉండాలి. ఒకసారి మీరు ఈ ప్రీవియస్ సెక్షన్స్ అబ్జర్వ్ చేయండి. సో ఇక్కడ ఎన్ని గేట్స్ ఉన్నాయి? టోటల్ 5 గేట్స్ ఉన్నాయి. ఓన్లీ NAND గేట్స్ ఓన్లీ NOR గేట్స్ యూజ్ చేసినా మనకు 5 గేట్స్ రిక్వైర్డ్ అవుతాయి. ఓకే, అండ్ ఇక్కడ ఒకసారి అబ్జర్వ్, ఓన్లీ బేసిక్ గేట్స్ యూజ్ చేస్తున్నాయి. ఓన్లీ బేసిక్ గేట్స్ యూజ్ చేస్తే 1 2 3 4 5 6 టోటల్ 6 గేట్స్ రిక్వైర్డ్ అవుతుంది. ఓకే, సో నెంబర్ ఆఫ్ గేట్స్ ఇంక్రీజ్ అవుతున్నాయంటే దాన్ని ఫ్యాబ్రికేట్ చేయాల్సిన స్పేస్ వచ్చేసి ఇంక్రీజ్ అవుతుంది. నెంబర్ ఆఫ్ గేట్స్ ఇంక్రీజ్ అవుతున్నాయంటే ఈచ్ గేట్కి దాన్ని యాక్టివేట్ చేయడానికి కావాల్సిన పవర్ సప్లై కూడా ఇంక్రీజ్. ఇక్కడ మొత్తం ఎన్ని గేట్స్ ఉన్నాయి? 4 + 2 6 గేట్స్ ఉన్నాయి. 6 గేట్స్కి మీరు పవర్ సప్లై అనేది అప్లై చేయాల్సి ఉంటుంది. అంటే పవర్ సప్లై అనేది వేస్ట్ అవుతూ ఉంటుంది, ఎక్కువ పవర్ నీడ్ అవుతుంది టు యాక్టివేట్ దిస్ పర్టికులర్ సర్క్యూట్ విత్ ద హెల్ప్ ఆఫ్ బేసిక్ గేట్స్. ఓకే, దట్ ఈస్ ద డ్రాబ్యాక్. ఓకే, అండ్ ఇఫ్ యూ అబ్జర్వ్ దిస్, XR and AND, only two gates are required, but XR is extra gate. Okay, my question is here the question is what? Realize half adder circuit with minimum number of gates by excluding XR XNOR logic. Okay, దీన్ని రిమూవ్ చేసేసి ఓన్లీ 5 గేట్స్ మాత్రమే యూజ్ చేసి లెస్ నెంబర్ ఆఫ్ గేట్స్తో ఈ హాఫ్ ఆర్డర్ ఫంక్షనాలిటీని ఇంప్లిమెంట్ చేయాలి. ఓకే, నాండ్ కానీ నార్ కానీ యూజ్ చేస్తే మనకి 5 గేట్స్ రిక్వైర్మెంట్ ఉంటుంది, ఓన్లీ బేసిక్ గేట్స్ యూజ్ చేస్తే 6 గేట్స్ ఉంటుంది. సో ఈ రెండింటిని కంబైన్ చేసి తక్కువ నెంబర్ ఆఫ్ గేట్స్తో ఈ ఫంక్షనాలిటీని ఇంప్లిమెంట్ చేయండి. అది నెక్స్ట్ క్వశ్చన్. ఓకే, అండ్ so what is the time now? 7. Okay. And last one, full adder. So our next topic is full adder. Okay, now it performs arithmetic sum of 3 inputs. Okay, 3 inputs. In the previous case, what happened? I am taking half adder. Okay, I am providing 2 inputs here. Okay, A, B. So finally, I am getting sum and carry. Okay, but now I am taking 3 inputs at a time, right? That means so this is our symbol, IEEE symbol. So IEEE, otherwise we can call it as ANSI symbol. So this is full adder. So here I am providing 3 inputs, A, B, C, and I am getting 2 outcomes. One is sum, another one is carry. Okay, so this A is called addend bit, this is agend bit, and this one is carry. Okay, and here sum S equals to okay, I will write Boolean expression later. First I will take okay, this sum and carry notations. So we can indicate with S and we can indicate with C. Okay, so these are the ABC 3 inputs. Okay, so this is ANSI IEEE logic symbol. Okay, now first to design this full adder circuit, in order to design this full adder circuit, first we want to know about the sum and carry expressions, Boolean expression. Okay, so in order to find out the sum and carry Boolean expression, first we focus on inputs. Okay, we have total 3 inputs. 3 inputs means what? 3 variables. 3 variables means what? Total 8 combination, that is from 0 to 7. First that you have to form the truth table. Okay, so the second one is truth table. First one is the logic symbol, otherwise IEEE symbol, and second one is the truth table. Okay, and okay, so here we have 3 inputs, right? Okay, here the outcomes are sum and carry. Okay, and this is our decimal numbers. Okay, oh, now here I am taking 0, 1, 2, 3, 4, 5, 6, 7. That was 2. Okay, now here the first combination is what? 0, 0, 0, 0, 0, 1, and 0, 1, 0, 0, 1, 1, and 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Okay, so these are the 8 combination, that is from 0 to 7, right? So now you can take the addition among these 3 bits. Okay, first I will focus on first combination 0, 0, 0. First you can add these 2 bits. Okay, first you can add these 2 bits, A plus B, that means 0 plus 0. Okay, why? Because this full adder, what it do, just it performs sum in between these three variables, right? So a plus b, b plus c, right? So now 0 plus 0, so we will get 0. 0 plus 0, ఈ రిజల్ట్ని దీనికి యాడ్ చేస్తున్నాను. ఓకే, డైరెక్ట్ ఈ 0 జీరోతో కాదు. ఓకే, ఏ ప్లస్ బి ఫస్ట్ ఈ అడిషన్ కంప్లీట్ చేసి వచ్చిన రిజల్ట్ని సితో యాడ్ చేస్తున్నాను. ఓకే, 0 ప్లస్ 0 ఇక్కడ ఏమవుతుంది, 0 అవుతుంది. ఆ 0ని మళ్ళీ దీంతో యాడ్ చేస్తున్నాను. అగైన్ ఐ విల్ గెట్ 0 ఓన్లీ. ఓకే, క్యారీ 0. నెక్స్ట్ సెకండ్ కాంబినేషన్ 0 ప్లస్ 0, ఐఎమ్ గెటింగ్ 0. Okay, that 0 can be added to this particular c value 1. So I am getting 1, carry 0. And 0 plus 1, 1. 1 plus 0, 1, carry 0. And 0 plus 1, 1. 1 plus 1. Okay, 1 plus 1 means what? Sum 0, carry 1. Okay. And next 1 plus 0, 1 plus 0, 1. 1 plus 0, 1, carry 0. And next 1 plus 0, 1. 1 plus 1, sum 0, carry 1. Okay. Next 1 plus 1, sum 0, carry 1. Okay. This is very important. Okay. Here I am indicating 1 plus 1. If I am adding these two bits, I am getting sum 0. The sum can be added to this particular value. Okay. And in the same way, here we are getting carry 1. Okay. 1 plus 1, sum 0. And this sum directly added to this particular value, and we are getting carry 1. That carry can be indicated here. Okay, so now you can add these two, 0 plus 0, I'm getting 0. Clear? And next, if you add these two, I'm getting a 0 sum carry 1. This carry directly I'm indicating here, and this 0 directly we can add to this particular c value. 0 plus 1, I'm getting 1. Okay, so this is your sum column. Okay, based on inputs and based on various combinations, I'm getting sum column like this, I'm getting carry column like this. Okay, with the help of this sum, the help of this carry, you can write the Boolean expression. Okay, you can write directly from this truth table, otherwise you can go for k-maps also to implement to realize Boolean expressions for sum and carry. Okay, I'm directly writing from this truth table. So whichever active combination is there, just I'm focusing on those combination, and I will write expression in terms of sum of product. Okay, so sum of product nature. Okay, first I am focusing on this element, so this is for sum. Okay, I'm writing for sum expression. Okay, this is 1. So for this one combination, 0 0 1, so 0 sum of product, so that a equals to 0 means a bar, b equals 0 means b bar, c equals 1 means c. So the first combination is what? A bar, b bar, c into this particular output 1 plus, and the second combination also our output is 1, so that a bar, b, c bar into 1 plus, and this fourth combination, this is output equals to 1. So for this, a, b bar, c bar into 1 plus, and this last one equals to 1. So here all the inputs are 1, so that I am taking a, b, c into 1. Now the sum s equals to a bar, b bar, c plus a bar, b, c bar plus a, b bar, c bar plus a, b, c. Okay, this is our Boolean expression, right? Now, okay, just you can leave it, and you can take carry. Okay, so here we have 1 1 1 1, right? So for this carry, okay, so the c equals to, now you can write for this one. Okay, so what are the combination? A bar, b, c into 1 plus, and the next one is what? This one. So a, b bar, c into 1. Okay, plus next one, so a, b, c bar plus, sorry, into 1 plus this last one, right? A, b, c into 1. Now, so first I will take sum here. Okay, sorry. Now I will take carry here. Okay, so sum is what? So here I am writing a bar b bar c plus a bar b c bar plus a b bar c bar plus a b c. This is the sum. And when it comes to carry, so a bar b c, a b bar c, a b c bar plus a b c. Okay, so this is a carry. Now you can simplify further. Okay, so for example, so I am taking XOR gate. Okay, so here I am providing A XOR B as one input and C is one more input for this XOR operation. Okay, now what you will get is I am here I am taking A XOR B whole bar into C plus A XOR B into C bar. This is one product term, this is another product. Already you know what is A bar, A XOR B, A bar B plus AB bar. That means one is complementary and another one is uncomplementary product term, right? So in the same way, just this entire A bar B I am considering as P. So that means this is P bar and this is P. That means P into P bar into C and P into C bar. Same as this XOR operation. Okay. So now you can simplify further this one. Okay. So I am writing here A B bar plus A bar B whole bar into C. This is one thing. And A bar, sorry, A B bar plus A bar B into C bar. Okay. Now you can expand this. So what you will get A, this is complementary principle for this. Okay. So what you will get A B bar whole bar into A bar B whole bar into C. Sorry, this is plus, right? Okay, sorry. Okay, now here you can multiply with the C bar. What you will get A B bar C bar plus A bar B C bar. Okay, and now you can simplify further this. Okay, what you will get? So this entire thing should be considered like A bar plus B bar whole bar based on complementary theorem. And for this entire thing, A bar whole bar plus B bar. Okay, now if you further simplify, you will get A bar plus B into A plus B bar. Okay, now so you will get finally A bar plus B and A plus B bar into C plus A B bar C bar plus A bar B C bar. If you simplify further these two, so A bar into A plus A bar into B bar plus B into A plus B into B bar. According to AND operation theorem, these two are 0. Then what you will get? So AB plus A bar B bar into C plus A B bar C bar plus A bar B C bar. Now what you will get? If you multiply with this C, so you will get A B C plus A bar B bar C plus A B bar C bar plus A bar B C bar, right? So once you compare this entire expression with this, okay, this entire expression, so just you can compare with this expression. So what you will get? ABC term is there, ABC term is there, okay. A bar B bar C, so this is A bar B bar C, and here A B bar C bar, right? So and here we have A B bar C bar, and if you observe this one, A bar B C bar, here we have A bar B bar. Now you can write this expression like, can I write A XOR B XOR C? So now here I am considering this as P and this is C. XOR operation between P and C. What you will get? P XOR C or not? Where P equals to what? A XOR B. Now if you combine these two, what you will get? A XOR B XOR C, right? Can I write like this or not? S equals to A XOR B XOR C. Okay. In the same way, if you simplify this carry, so what you will get? If I am taking, so here we have AB, here we have AB, right? So from these two product terms, so I can take AB as a common factor, then I will get C plus C bar. So according to our operation theorem, this should be 1. So what you will get? AB, right? Now I am taking A bar BC plus A B bar C into AB, right? Okay. Otherwise I will take one more page. Okay. So C equals to A bar BC plus A B bar C and A B C bar plus A B C. Okay. From these two terms, I am getting AB. Okay. Now I will take C equals to A bar BC plus A B bar C plus AB. Right. Now, so just I will take A as a common factor from these two terms. Now A bar BC plus I will take A as a common factor. Then I am getting B bar C plus B. Okay. So from distribution theorem, so what you can write from this? So I am writing B plus C into B plus C into B plus B bar according to distribution theorem. Okay. So this B plus B bar equals what? 1. So what you will get? B plus C. Now A bar BC plus A into B plus C. If you simplify further, so A bar BC plus AB plus AC. Okay. Now you compare these two, then what you will get? To take B as a common factor, A bar C plus A plus AC. Now, so again you can apply a distribution theorem for this. Okay. What you will get? So B A plus A bar into A plus C. Okay. Plus AC. So this A plus A bar equals to 1. So now what you will get? AB plus BC plus AC. So this is your carry. Okay. So carry C equals to AB plus BC plus AC. So this is your carry, right? Okay. Now, so this is our full adder. Okay. So here I am providing 3 inputs, that is A, B, C. I am getting 2 outputs, that is sum. So that sum S equals to A XOR B XOR C, and the carry C equals to AB plus AC plus BC. Okay. So these are the Boolean expressions. Clear? Now, okay. So first part is over. So Boolean expression find out చేసాం. ఈ Boolean expression నుంచి వెళ్ళి లాజిక్ డయాగ్రామ్ ని ఇంప్లిమెంట్ చేయాలి. ఓకే. సో ఎలా ఇంప్లిమెంట్ చేస్తారు? ఆల్రెడీ ఏ ఎక్స్ఆర్ బికి ఎక్స్ఆర్ తీసేసుకుంటాం. ఈ కంప్లీట్ టర్మ్కి ఏ ఎక్స్ఆర్ బి ఎక్స్ఆర్ సికి ఇంకొక ఎక్స్ఆర్ గేట్ అనేది రిక్వైర్మెంట్ ఉంది. అంటే ఇక్కడ కంప్లీట్గా మనకి 3 ఇన్పుట్ ఎక్స్ఆర్ ఆపరేషన్కి 2 ఇన్పుట్ ఎక్స్ఆర్ గేట్స్ వచ్చేసి 2 రిక్వైర్డ్ అవుతాయి. ఓకే. అదర్వైజ్ లాజిక్ సర్క్యూట్ ఇంప్లిమెంటేషన్. ఓకే. సో ఫస్ట్ ఏ ఎక్స్ఆర్ బిని ఇంప్లిమెంట్ చేయాలి. మనకు ఒక ఎక్స్ఆర్ గేట్ వచ్చేసి రిక్వైర్మెంట్ ఉంటుంది, దట్ ఈస్ 2 ఇన్పుట్ నాట్ 3 ఇన్పుట్, రైట్? సో ఇప్పుడు ఏ ఎక్స్ఆర్ బి ఎంటైర్ థింగ్ని సితో ఎక్స్ఆర్ ఆపరేషన్ చేయాల్సి ఉంటుంది. సో దానికి ఇంకొక ఎక్స్ఆర్ గేట్ అనేది రిక్వైర్డ్ అవుతుంది, 2 ఇన్పుట్ ఎక్స్ఆర్ గేట్. అంటే టోటల్ మనకి 2 ఎక్స్ఆర్ గేట్స్ రిక్వైర్డ్ అవుతాయి. ఇక్కడ మనకి ఏబి, ఏసీ, బీసీ టోటల్ 3 ప్రోడక్ట్ టర్మ్స్. ఓకే. ఈ 3 ప్రోడక్ట్ టర్మ్స్కి మనకి 3 AND గేట్స్ అనేది రిక్వైర్డ్ అవుతాయి. 3 AND గేట్స్. ఓకే, నార్మల్గా అయితే. ఓకే, బట్ ఏదైనా లాజిక్ ఉంటుందా అనేది మనం వెరిఫై చేద్దాం, అంటే తక్కువ నెంబర్ ఆఫ్ గేట్స్తో ఇంప్లిమెంట్ చేయడానికి. ఓకే, ఫర్ ఎగ్జాంపుల్ హియర్ ఐఎమ్ టేకింగ్ అండ్ ఈ 3 AND గేట్స్ కూడా మనకి యాడ్ చేస్తున్నాం ఇక్కడ ఏబీ ప్లస్ ఏసీ ప్లస్ బీసీ. సో ఎన్నిసార్లు యాడ్ చేస్తున్నాం మనం ఇక్కడ 2 టైమ్స్ యాడ్ చేస్తున్నాం. అదే 3 ఇన్పుట్ ఆర్ గేట్ అయితే ఒకటి సరిపోతుంది. ఓకే, 3 ఇన్పుట్ ఆర్ గేట్ అయితే 1 ఈజ్ ఎనఫ్. ఓకే, ఒకవేళ 2 ఇన్పుట్ ఆర్ గేట్ తీసుకున్నాం అనుకోండి, అప్పుడు మనకి 2 ఆర్ గేట్స్ వచ్చేసి రిక్వైర్డ్ అవుతాయి. ఓకే, అర్థమవుతుంది కదా. 1 product term should be considered as 1 input for OR gate. Okay, for products point of view we are taking AND gates. For some point of view we have to go for OR gates. Here we have 3 inputs to OR gate. So for 3 input OR gate we require 1. If you go with the 2 input OR gate, we require 2 to implement this carry, right? So now here I am taking first some implementation. So first I will take one XOR gate. Here I am providing 2 inputs, those are A and B. Okay, so finally I am getting here A XOR B. So now this will provide input to second XOR gate, and so this is okay, A XOR B, and this is C. So finally here I will get S equals to A XOR B XOR C. Okay, now this is your C input. Okay, and next I want to implement this carry part. Okay, so in that case first I will take AND gates, 3 AND gates. Okay, these are the 3 AND gates. Okay, first I will take connection from A. Okay, and next I will take the connection from B. Okay, and next A, and next C. Okay, and next B and C. Okay, B, C. Okay, so this is A, and this is B, this is A, this is C, this is B, and this is C. So here I am getting AB, AC, and BC. So now you can add these all 3 product terms. For that you required a 3 input OR gate. Okay, so here you are getting carry AB plus BC plus C. Okay, like that you can form the circuit. So now this is your black box. Okay, this is your full adder circuit implementation. Okay, to implement this full adder we require 2 XOR gates and 3 AND gates, 1 OR gate, 3 input OR gate. ఒకవేళ 2 input OR gate యూజ్ చేయాల్సి వస్తే ఫస్ట్ AB ఇన్పుట్స్ తీసుకోండి, AB and BC, and these two are added with one OR gate, and the resultant should be connected to some other OR gate, AB plus BC, and here AC, and again you need to add here so that you will get carry here. So we require 2 input OR gates are 2, 3 input OR gate is 1. Okay, so this is the implementation of full adder circuit, right? So and the next one, so these are a combination of all gates, all logic gates. Here I am using extra gates, and here I am using basic gates also. Okay, now what you have to do, just you can take only basic gates. Okay, first thing is implement full adder with basic gates only. Okay, basic gates only. And the second one, implement full adder with only NAND gates, only NAND gates. Okay, and the third one, implement full adder with only NOR gates. Okay, and fourth one, implement full adder with half adders. Okay, implement full adder with half adders. Okay, so here to implement full adder with universal gates, so we require number of NAND gates. Okay, number of NAND gates are 9. Okay, 9 gates are required. Okay, in the same way, so number of NOR gates required 9. Okay, ఇది నేను ప్రొవైడ్ చేస్తున్నా ఆన్సర్. ఓకే, హింట్ ఇస్తున్నాను, సో మీరు ఇంప్లిమెంట్ చేయండి. ఓకే, ఎంట్రన్స్ పాయింట్ గేట్ పాయింట్ ఆఫ్ లో దీస్ ఆర్ ఇంపార్టెంట్, గేట్ అండ్ ESC పాయింట్ ఆఫ్ లో. సో నెంబర్ ఆఫ్ NAND gates 9 and number of NOR gates 9. Just you can implement that particular circuit diagram. Okay, and implement full adder with a half adder. First you can take one half adder. Okay, this is your half adder. So here I am providing two inputs A and B. This is IEEE symbol. So sum and carry. The sum equals to what? Otherwise I am writing sum and carry. Okay, so here sum equals to what? A XOR B, and carry equals to what? AB. That is clear, right? Now I will take one more half adder here. Okay, so this is half adder. Okay, now I am providing C input to the second half adder directly, and I will take first input from first half adder, that is A XOR B. So finally here I am getting a sum, that is A XOR B XOR C, right? Why? Because this is A XOR B input and this is C input with this full adder. So then I will get S equals to A XOR B XOR C, right? Now I want to implement carry. That carry C equals to what? AB plus BC plus CA. Now I have to implement this. For this implementation I require, here I am getting carry AB, right? This is AB. Okay, here I have AB. Okay, now so wait, so this is, sorry, so this is carry. This carry between these two elements, right? Here we are providing inputs A and B. Finally I am getting carry AB. Here I am providing A XOR B C as input to this particular half adder, so that I am getting A XOR B into C, product of these two inputs, right? Here also we are getting product of these two, AB, right? Here also we are getting same thing. Now you can add these two. Okay, now you can add these two. So how you add? With the help of OR gate. So I am getting A XOR B into C plus AB. So this will give AB plus BC plus CA. Okay, this is your carry. Okay, that means we require two half adders, one OR gate to implement this particular logic. Implement full adder with half adder means we require two half adders plus one OR gate. Okay, so these all are entrance related questions. Okay, so you can solve these three questions: implement full adder with basic gates, implement full adder with only NAND gates, implement full adder with only NOR gates. Okay, these three you have to solve. Okay, మీరు నాకు సబ్మిట్ చేయాల్సిన అవసరం లేదు, మీరు సాల్వ్ చేసేసుకోండి. ఓకే, ఆల్రెడీ DC రిలేటెడ్ అన్ని అసైన్మెంట్స్ అంతా ఓవర్, బట్ నేను పర్సనల్గా ఇచ్చేస్తున్నాను. మీరు సాల్వ్ చేసుకుంటే అది మీకు ఓకే, మీరు సాల్వ్ చేయకపోతే అది మీ హెడేక్ ఇంకా. ఓకే, so this is about half adder and full adder, and in the next session I will discuss half subtractor and full subtractor. Okay, I hope you understood these topics, right? సో ఈ రియలైజేషన్ పార్ట్లో మీరు ఫస్ట్ చేయాల్సింది ఏంటంటే, ఇన్పుట్ ఏదైతే ప్రాబ్లమ్ స్టేట్మెంట్ ఉంటుందో ఆ ప్రాబ్లమ్ స్టేట్మెంట్ నుంచి వెళ్ళి ఇన్పుట్ ఏంటి, అవుట్పుట్ ఏంటి, ఆ క్లాసిఫికేషన్ అనేది చాలా ఇంపార్టెంట్. ఓకే, వెయిట్ ఏ మినిట్. ఓకే, మీకు ప్రాబ్లమ్ స్టేట్మెంట్, ఓకే, డిజిటల్ ఎలక్ట్రానిక్స్ పాయింట్ ఆఫ్ వ్యూలో ప్రాబ్లమ్ స్టేట్మెంట్ ఏదైతే ప్రొవైడ్ చేస్తారో ఆ ప్రాబ్లమ్ స్టేట్మెంట్ నుంచి వెళ్ళి అసలు ఫస్ట్ ఏం అడిగాడు క్వశ్చన్, ఓకే, అసలు ఇన్పుట్ ఏమి ఇచ్చాడు, అవుట్పుట్ ఏం అడుగుతున్నాడు, ఓకే. సో ఇన్పుట్ని అవుట్పుట్ని బేస్ చేసుకొని మధ్యలో కావాల్సిన సిస్టమ్ ఏంటి, ఈ త్రీ థింగ్సే మనకి ఇంపార్టెంట్, ఓకే. ఫస్ట్ ప్రాబ్లమ్ స్టేట్మెంట్ అర్థం చేసుకోవాలి. సో వాట్ ఆర్ ద ఇన్పుట్స్ దే ఆర్ ప్రొవైడింగ్, సో వాట్ ఆర్ ద అవుట్పుట్స్ దే ఆర్ ఎక్స్పెక్టింగ్, and what is the system we have to implement. So these three things are important, okay. So problem statement నుంచి ఫస్ట్ ఈ టైప్ ఆఫ్ అరేంజ్మెంట్ అనేది మీరు కంప్లీట్ చేసుకోవాలి. దాని తర్వాత ఈ అరేంజ్మెంట్ బేస్ చేసుకొని ట్రూత్ టేబుల్ వచ్చేసి ఇంప్లిమెంట్ చేయాల్సి ఉంటుంది, ఓకే. దిస్ ఇస్ ఫస్ట్ స్టెప్, దిస్ ఇస్ స్టెప్ 2. స్టెప్ 1, స్టెప్ 2లో మీరు ట్రూత్ టేబుల్ ఇంప్లిమెంట్ చేయాల్సి ఉంటుంది. స్టెప్ 2 ట్రూత్ టేబుల్, ఓకే. ఈ ట్రూత్ టేబుల్ నుంచి వెళ్ళి కే మ్యాప్, ఓకే, కే మ్యాప్ ఇంప్లిమెంటేషన్. కే మ్యాప్ నుంచి వెళ్ళి కే మ్యాప్ ఎందుకు యూజ్ చేస్తున్నాము అంటే బూలియన్ ఎక్స్ప్రెషన్ కోసం, ఓకే, బూలియన్ ఎక్స్ప్రెషన్. ఫ్రమ్ దిస్ బూలియన్ ఎక్స్ప్రెషన్ యూ కెన్ ఇంప్లిమెంట్ లాజిక్ సర్క్యూట్, ఓకే. ఫ్రమ్ దిస్ ఇంప్లిమెంటేషన్ యూ కెన్ ఇంప్లిమెంట్ లాజిక్ సర్క్యూట్. సో దిస్ ఈస్ ద వే యూ హ్యావ్ టు సాల్వ్ ద ప్రాబ్లమ్ ఫ్రమ్ డిజిటల్ సర్క్యూట్స్, ఓకే. మీ క్వశ్చన్ ఎలా అయినా అడగచ్చు. ఇన్పుట్ డేటా కంప్లీట్గా ప్రొవైడ్ చేసేసి ఫైనల్ లాజిక్ సర్క్యూట్ అడగచ్చు, లేదంటే లాజిక్ సర్క్యూట్ ప్రొవైడ్ చేసేసి మీకు అసలు ఈ అరేంజ్మెంట్ కూడా అడగచ్చు, లేదంటే కే మ్యాప్ అడగచ్చు, ట్రూత్ టేబుల్ అడగచ్చు, ఓకే. డిఫరెంట్ వేస్లో మూవ్ అవ్వచ్చు, ఓకే. సో దిస్ ఈజ్ అబౌట్ కాంబినేషనల్ సర్క్యూట్స్, హాఫ్ యాడర్ అండ్ ఫుల్ యాడర్, ఓకే, రైట్. సో ఎనీ డౌట్స్? ఓకే, టోటల్ 58 మెంబర్స్ లైవ్లో ఉన్నారు. రెస్ట్ ఆఫ్ ద స్టూడెంట్స్ ఏంటి వాళ్ళ పరిస్థితి? 330 మెంబర్స్ కదా. ఓకే, ఇందులో ఏమైనా డౌట్స్ ఉన్నాయా ఈ 2 టాపిక్స్లో, హాఫ్ యాడర్ అండ్ ఫుల్ యాడర్? ఈస్ దెర్ ఎనీ డౌట్స్ ఫ్రమ్ దీస్ 2 టాపిక్స్? మీకు డౌట్స్ ఏం లేవు అంటే క్లోజ్ చేసేస్తాను సెషన్. ఓకే, రైట్. టైమింగ్స్ ఓకేనా మీకు, అంటే 4 to 6? వాట్ అబౌట్ మల్టీ యాడరా? మల్టీ యాడర్ ఏమి ఉండదు నాన్న. ఇన్ కేస్ మీకు మల్టీ యాడర్ కావాలి అని అంటే ఈ హాఫ్ యాడర్స్ని యూజ్ చేసుకొని ఇంప్లిమెంట్ చేయొచ్చు, ఫుల్ యాడర్స్ని యూజ్ చేసుకొని అయినా ఇంప్లిమెంట్ చేయొచ్చు. These are the fundamentals: half adder, full adder, okay. With the help of those 2 adders you can implement any number of bits, okay. అప్లోడ్ బీడబ్ల్యూ వీడియోస్ సార్, ఆల్రెడీ అది అప్లోడ్ అయిపోయి ఉంది, ఓకే. ఈ లైవ్ అయిపోయిన వెంటనే డైరెక్ట్ యూట్యూబ్లోకి వెళ్ళిపోతుంది, మళ్ళీ నేను స్పెషల్గా అప్లోడ్ చేయాల్సిన అవసరం ఉంది, అందుకనే లైవ్ చూజ్ చేసుకున్నాను. ఓకే, రైట్. ఇన్ కేస్ మీకు ఏమైనా డౌట్స్ ఉంటే కనుక డైరెక్ట్ వాట్సాప్ గ్రూప్లో పోస్ట్ చేయండి, ఓకేనా? ఓకే, థ్యాంక్ యూ.